Hi, I'm Josh, and this is Electronics Unscripted, where we take an intuitive and unscripted approach to DIY electronics. I was poking around on YouTube, and there's this channel that, every day has, this amazing module you can get from Aliexpress for $1. And I'm like, great. So they show us this really cheap DC to DC boost power supply. And I think when I first saw it, I was looking to charge up some batteries that needed 40 volts, and I didn't really have anything in my workshop here that was capable of delivering that many volts at significant amperage. So I'm like, oh, that's cool. Let's try it out. So I tried it out, and I did a little bit more rigorous inspection of this equipment. And yeah, well, this video is our exploration in depth of how these El Cheapo Aliexpress Boost DC to DC converters actually work. What claims are true, what claims are false, what sorts of caveats do you need to look out for? Let's take a look at this thing and actually see what it can do. So here we have it on AliExpress. There are probably dozens of listings that are very similar to this. I'm not sure if they're the same, if they're clones, what have you. This one seems to be reasonably legit. It does work out of the box, and it does kind of what it says it should. We're going to check it out. We're going to put it through its paces. I've also got my portable oscilloscope, and we're going to put that through its paces and see how it does, taking a look at the output of this. You'll notice that this says that it is a 400 watt, 15 amp. 15 amp, 400 watt. No, I don't think so, and I think we're gonna find some limits here. So let's read through this here. So it says module name 400 watt boost constant current module. Non-isolated boost module. Input voltage goes from 8.5 volts up to 50 volts. Okay, I'm not sure we're going to test that. Input current 15 amps max. Over 8 amps, please strengthen heat dissipation. That's important. So if I'm stepping 12 volts up to 48 volts, I will get a quarter of the amps in the output that I have on the input. So 8 amps on the input then becomes 2 amps on the output. So that's important to realize. Probably about the most you're going to get out of this module is 2 amps, and it's telling you that on the tin, and it's probably actually going to be a little less than this depending on your voltage. Working temperature, it says the working frequency is 150 kilohertz, and we can check that out. Conversion efficiency up to 96% efficient. I think that's unlikely, but we'll see how good it does. Overcurrent protection. Yes, if the input exceeds 15 amps, the output voltage will be automatically reduced. Yes, it will be reduced because the MOSFETs will burn out. I've actually already burnt out one of these, and I've come close to burning out a second one. Voltage regulation. So here we have a picture of the circuit. So we have input plus and minus, output plus and minus, and then it has a voltage regulation multi-turn potentiometer and a current regulation multi-turn potentiometer. It says you can adjust the CV constant voltage adjustment and then the constant current adjustment. And I think the idea here is, when you want to charge a battery, typically you want a current limit on the battery as you're charging it. This says that it will limit current. I don't really have a battery to charge. I do have my adjustable electronic load here, so we can see if it limits current or not. See how effective that feature is. But it's important to charging batteries because typically you want to spend a large amount of time where you're not hitting the pack voltage and you're just limiting current. So you don't want a huge inrush of current early on. And then once you reach the point where the pack starts ramping down the amount of current that it will accept, you start to increase the voltage up to the maximum pack voltage. Then you kind of top it off at a very low amperage. I think the idea here is that you could use this to charge a battery pack. And it says DIY regulated power supply, input 12 volts, output can be 12 volts to 50 volts adjustable. For your electronic power supply, you can set the output value according to your system voltage. As a vehicle power supply for your laptop, PDA, or various digital products, DIY as a high-power notebook mobile power supply with a large capacity. With a large capacity 12 volt, your notebook will light up wherever you go. 12 volt lithium battery pack, I don't know. Solar panel voltage regulator. I mean, I guess it is a DC to DC converter, so you could use it in that sense. I don't know. Charge batteries, lithium batteries, etc. Yep. Drive high power LED lamp. And there's a nice little close-up picture of it. We've got our nice little inductor, a couple MOSFETs, some capacitors on the in and out, and there's a chip in there. As far as I can see, this is an actual legit TI regulator. It could be a knockoff, but it appears to be doing what the TI datasheet says it's doing. So let's take a look at it first and put it through its paces. So I'm going to turn on my bench power supply, which is connected in here. I've got some relatively beefy cables. In a previous test, I actually melted some of these little wires. So if we run this up to higher amperage, we really do need beefier wires here. Turn on my bench power supply and see what we see. So right now I'm set to 40 volts output. First thing we're going to do is we're going to turn this potentiometer clockwise to see what the lowest voltage is. So we're providing 12 volts input, and let's see how far down the output will go. So now what we're going to do is we're going to take the power supply through its paces. We were down to the absolute lowest that it can go, which is about 11.5 volts. And let's just put a little bit lighter load on here, so about 160 milliamps. Theoretically, it shouldn't be able to go below 12 volts, probably just some sort of switching losses and so forth. And we're going to turn it counterclockwise here, the voltage adjustment. See what happens. Get up to a reasonable boost here. Let's go for like about 20 volts. And you should be able to see the wattage go up as the voltage goes up. That's because the electronic load has a fixed current that it's asking from this power supply. So as the voltage goes up, power equals volts times amps, so the power increases. So let's go ahead and hit 20 volts here. And we've got the scope in AC coupling mode here, so we're not seeing the absolute output in voltage. What we're doing is we're seeing the ripple on the voltage. So it's kind of going crazy as I adjust it. Let's do an auto range on this. I think sometimes it gets a little confused. There we go. So if I give it a little bit more juice, so now we're up to 350 milliamps, and now we're seeing a good picture of the ripple. So this is the switching noise of the MOSFETs in the power supply here. So there's two MOSFETs, and they're going to generate noise on the output rail. And you can see it's pretty significant. It's a couple hundred millivolts above and a couple hundred millivolts below as well. So, you know, we're talking a half to a full volt of switching noise, a ripple in this output. I've got the fast Fourier transform here. Fast Fourier transform, what that does is give you an idea of the frequency components of the signal that you're looking at. And this is bouncing around quite a lot, but you can see the frequency here is at 111 kilohertz. That's close to the 150 kilohertz that the website claims, not quite exactly. You know, maybe this one's just adjusted slightly differently. So we've got it up to 20 volts. Let's see how high it goes. You can see we're almost at 30 volts and the ripple has gotten worse. So the ripple is even higher than it was before. You can see the ripple, as I turn down the amperage, the ripple gets lower. As I turn up the amperage, the ripple gets more, increases. This is a relatively noisy power supply. It would probably be fine for charging batteries. I would not power any sort of electronics with this. So let's just see how high a voltage we can hit here. So 37, 48. See the ripple. The ripple on our scope is getting somewhat extreme here. 1.5 to 2 volts of ripple. So we're at 53 volts. I'm going to auto range this again. Now that looks a little bit better. Okay, yeah, so we've got 2 volts. So, you know, we've got like a good 2 volts of ripple here. That is a non-trivial amount. And we're still rock solid at that frequency of 111. We are pulling 500 milliamps or 0.5 amps here on the bench power supply. We have 12 volts at 2.3 amps. And I think now would be a good time to take a look at the claimed efficiency. We are pulling 26.3 watts here. And on the bench power supply, we're pulling 28.5. So that's 92% efficiency. So that's actually not bad. 92% efficiency for a DC to DC power supply. That's great. That is not up to 96% efficiency. I don't think we're going to hit that in any way, shape, or form. But let's go further. Let's see how high a voltage we can hit with this guy. So 62. And I want to be careful here not to release any magic smoke, not to shock myself. We're getting up to voltage ranges where we can spark things pretty easily. So 67 volts. And that, it looks like we're at about the limit here. So this is actually above what it claimed in the, so it says 10 to 60 volts continuously adjustable. So it goes up to 67 volts. Because we're at such a high voltage multiplier over the 12 volts, if I'm pulling, say, 450 milliamps here on the bench power supply, we're at about 3.7 amps. We have that amp divider going on here because we're multiplying the voltage by over 5. We're dividing the amps out by over 5 as well. Let's turn this down to a little bit more sane voltage. Let's go for like 41 volts or 42 volts, which is what I might use to charge a 40-volt lithium ion. Ooh, that's getting hot. Why is that getting hot? Wow, that is super hot. That's okay. So we're not, at least we're cooling down now. I'm not exactly sure why it got that hot. I've had some occasions where suddenly this MOSFET just gets incredibly hot for no particularly good reason. I think the regulator gets confused and starts doing some very stupid things. You don't want to operate this thing on the higher end of its current limit. So we're getting a good amount of ripple here. We're at 42 volts at about a 500 milliamps, and we're seeing 2 amps on the bench power supply at 12 volts. So we're having roughly a quartering of the amps out, and we're quadrupling the voltage out, roughly. Let's take a look at the efficiency again. I'm going to call that roughly 20 watts out, and it's 21.5 in. So that's 93%, and I think we had 92% last time. So in the low 90% efficiency, which is great. Let's take a look at the heat profile right now. Doesn't look too bad. 53 degrees Celsius is pretty respectable. But let's give it a stress test. I'm going to up the amperage limit to about 8 amps. I need to watch this very, very carefully. I lost a board to that, so I kind of salvaged the components out of it. But you can see I melted the little rubber fitting around the screw that just totally melted. So this thing went well up over 200 degrees Celsius. I think it was 300 degrees Celsius. Like it really got toasty. So I was able to harvest some nice components. I've got some nice little heat sinks that I can strap to my MOSFETs, some 200 microfarad capacitors, and some unspecified inductor. That might be useful for some future project. And if you look really close here, we should be actually able to see, what the chip is. There we go. So we can take a look at the data sheet on that. So I'm going to go up to about an amp here. So that's roughly 1 amp. And we're getting 3.4 amps on the input. And we're pretty safe temperature-wise here. See, the max is about 50 degrees Celsius. Not a big deal. You can see the ripple on the scope is going higher as I go higher in my current. I think we can hit 1.5 amps here. Yeah, so 1.5 amps on the output. So we get 42 volts on the output, 1.5 amps, 12 volts on the input with 5.5 amps on the input. And we don't seem to be having much of a problem here at this level. So let's take it up a little bit more. And we hit 2 amps. The power supply is getting happy now. He's operating at about 90 watts. You can see we're outputting about 80 watts. So we're pushing a good amount of power through there. We're getting nowhere near 400 watts. Nowhere near it. But you can hear the power supply's fans just turned on. That's because we're getting up near about 100 watts of output. So we got 12 volts at 7.5 amps, which gives us about 91 watts of output for the power supply. See, we've got about 81 or about 80 watts of output down here at 41 volts at 1.89. So I think we can get it about 2 amps. And I think this is roughly where I want to limit it. And I think we're going to see those MOSFETs starting to heat up here. Yeah, so he's at 58 degrees Celsius, so that's about 10 degrees warmer than he was before. You can see our ripple here is getting quite insane. We've got roughly 2 volts of ripple. That's a little bit out of control. MOSFET is warming up a little bit more. I'm just a little concerned because at about this level of output, I have had this thing kind of fall off a cliff where it just suddenly heated up dramatically. Let's see. Let's give it, I'm going to give it 10 amps, which is close to the limit of our power supply here, at least at this voltage. We're going to go up and just kind of watch and make sure. So we can see the there we just did it. Yeah, so you can see it just spiked. That temperature spiked dramatically. I just turned off the current, so it's cooling down, but we went off a deep end there. So I would say 8 amps on the input, around 100 watts on the input, and obviously minus 10% for the output for the switching losses. That's where you're going to live. And I think we caught it quickly enough. We didn't burn it out, but I believe that's how I burn out the other one. Like, I was just at the bare edge, and it's totally right. It says, like, if you go above 8 amps, you need some extra cooling. Boy, you need a lot of cooling because that heated up tremendously quickly. So we're at 2 amps, roughly the limit of what I would say is reasonable to get out of this. So 2 amps here gives us about 7.7 amps on the bench power supply, and that's 92 watts of output. Again, nowhere near close to our 400 watts claimed. Let's take this up a little bit higher. So we're still in a good temperature range here. We're not bad. 2.15 amps. So we're at 70 degrees Celsius on the MOSFET. It's getting a little toasty. We're at 9 amps. And I've seen this thing just take off even in the steady state. We just went over 108 watts on the bench power supply, and we're at 94 watts here on my electronic load, 70 degrees Celsius, so we're getting pretty toasty. 75 degrees Celsius on that MOSFET. Good amount of ripple. I would say probably 3 volts of ripple on the output. That's kind of insane. But it's doing it. We're getting a steady state of about 115 watts into this thing and about 100 watts out of it. So that's, that's reasonable. Like I said, I think this thing falls. I would not leave this thing just sitting around like this. I think it's going to fall over at some point, and it's going to thermally spiral out of control. That's quite hot to the touch. So we're hitting 80 degrees Celsius now at 9.5 amps on the input and 115 watts on the input. So again, we're getting nowhere near 400 watts input or output. I'm not sure how you would be able to do that. It seems we've reached a reasonable steady state at about 2.5 amps on the output and 10 amps on the input. I wouldn't operate it in this range because I've had them blow up at this range. I mean, I think they're at the bare limit of their operating range. I would run loads at most 1 amp to 1.5 amps. If you're looking to charge, say, a bike battery pack or something like that, like an 8 amp hour or a 10 amp hour, it's going to take 8 to 10 hours to charge something like that. That's pretty reasonable. I wouldn't leave this thing sitting alone, though. It will probably burn out and short on its own. I don't know. Let's go ahead. And that's a weird thing too, that failure mode, I just turned up the amperage just a little too high, And the failure mode of the power supply is basically, it fails as almost like a dead short, and it shorts out the power supply. And I'm not exactly sure why it does that. I don't think I burn it out. Let's take a look and see. Yeah, we're still pretty hot. So it got hot in just a couple seconds. And I think that's because it was absolutely shorted out. It doesn't look too toasty. I turned my, yeah. So he's still regulating. So we're back to reasonable levels of ripple, reasonable levels of output. So this module does appear to be an adjustable power supply. Let's evaluate its claims. 400 watts, no. We got up to about 115 watts, and I don't think it was stable there. Input voltage, DC 8.5 volts to 50 volts. We didn't really try different input voltages. We just stuck it to 12 volts. I did play around with it kind of off screen, and it will take various input voltages. That's fine, great. Input current, 15 amps max. It says over 8 amps. Please strengthen heat dissipation. Yes. Just with these radiative coolers, it's definitely not going to be able to hack it above 8 amps. And even 7 amps seemed to like a little bit sketchy. Output voltage, 10 to 60 volts. We took it all the way up to 67 volts. So definitely it made that. Output current, if 12 amps max exceeded 7 amps, please strengthen heat. Again, this has to do with the voltage multiplier. So if you're using a step-up converter, you're probably going to be doing 2x anyway. So if your max current is 8 amps on the input side, the output current max should be about 4 amps. I have no idea where it's getting this 400 watts. The maximum wattage we saw into this was about 115 watts. It's not going to touch 400 watts any way, shape, or form. So in the end, how did this $3 Aliexpress Boost Converter perform? Well, I mean, it is a DC to DC boost power supply. It doesn't perform well though. It's limited to about 100 kilohertz, which isn't a great switching frequency for a power supply. You're going to have a relatively noisy power supply, and we saw that in our testing with the oscilloscope. They had quite a lot of ripple, and especially under heavy load, we had significant amounts of ripple. And this limits the application of this. You're not going to use this to power any sort of sensitive equipment. There's just no way. So I really think it's designed to be a battery charger. If you have a 12-volt power supply, just like a 12-volt brick or a 9-volt brick or something like that, you can plug this into it, boost it up to 40 or 50 volts, and charge a relatively beefy battery. The problem is that I couldn't get this thing's current limiting mode to work. Right on the tin, it says that it has a constant current mode, and constant current is an important part of battery charging. You want to charge most of the battery charging cycle is in constant current mode. You want to limit the amount of current because a battery will suck a lot more current than it should from a charger, and this module won't stop it from doing that. It might burn out. It might just fail, but there's nothing inherently in this module. I turned that potentiometer, the current limiting potentiometer, 30 turns in each direction, and it didn't do a darn thing. It never limited the current out of this module. In the end, you get what you pay for, right? That's it. And $3 power supply from AliExpress is worth about $3. If you know what it is, if you know what it can do, you might be able to find some applications for it. I can't imagine how I would use this in my shop. I don't know what I would do with it. This thing didn't come anywhere close to the 400 watts and 15 amps that it claims in its webpage on AliExpress. Nowhere near. Now, it did have a warning saying that if you went above 8 amps, you needed extra cooling, and we certainly saw that. We saw that the MOSFET kind of fell over a cliff and superheated very, very quickly when we got up into the 7 and 8 amp range, and certainly above 8 amps on the input. I would classify this as utterly unstable without some other form of very aggressive cooling. I don't think that really makes much sense. You shouldn't be using this small of a power supply for 400 watts. Like, there's a reason my bench power supply that provides 300 watts is like 10 times as big as this thing. There's a reason. They put more stuff in it. And this thing doesn't have a lot of stuff. It is the bare minimum that you could possibly need to be a Boost power supply. So again, you get what you pay for. Thank you for watching to the end. Please leave any questions in the comments.